Okay, on our next part, we're going to do some more examples of triangle similarity where we're trying to find missing sides. On number one, we have like our flagpole problem. We have, two triangles. One's kind of inside the other. And all we have to do is match up sides. Let's see. Let's start with the 36 on the big triangle. So the 36 on the big triangle is going to match with the 24 on the small triangle. And then on the other side, we have the missing side on the big triangle. It's going to match with the 28 on the small triangle. So then we cross multiply with 24x is equal to 36 times 28. And that means 24x is equal to 1008. And then we divide by 24. And we'll get x is equal to 42. On number two, it's another example of the triangle inside the other triangle. And we'll match up sides. Let's start with the missing side this time. So the missing side is on the big triangle, and it matches with the 16 on the small triangle. And then on the other side, we have the 27 on the big triangle, and it matches with the 18. So if we cross multiply, we'll get x times 18, which is 18x, equals 16 times 27. And 16 times 27 is 432. So we get 18x is equal to 432. Then we divide both sides by 18. And we'll get x is equal to 24. On number three, these triangles are not similar. Or I'm sorry, they are similar, but they're not one triangle inside of the other triangle. And this one, I kind of want to look at two things. So first, this symbol means similar. So I have triangle FGH is similar to triangle LMN. And then we can kind of match up the angles and sides. So if we look, FG comes first, so it matches with LM. And GH matches with MN, and FH matches with LN. We can also look on the picture. They gave us an angle, the 56. So L matches with F, and you notice how they're both in the first positions. Okay, so we have enough. We can match up the sides even though they're not in the same orientation. So let's see what we can do. Let's start with the 30. 30 is on LM, and LM is my first and second letter, so it matches with FG, which is our 70. We have 30 matching with 70. And then our missing side is going to match up with LN, which is our first and third, so it matches with FH, which is a 63. Then we cross multiply. We'll get 70 times x equals 30 times 63. And 30 times 63 is going to be 1,890. Divide both sides by 70. And we'll get x is equal to 27. Okay, number 4 is another one of those examples where a triangle is inside the other triangle. So these are pretty easy to match up sides. The 24 matches up with the missing side. And then the 22 matches with the 11. Okay, we'll cross multiply. We'll do 24 times 11 equals 22 times x. And 24 times 11 is 264. Then divide both sides by 22. And we'll get x is equal to 12. Okay, last example. The triangle EFG is similar to triangle ETU. And let's see what I have. I have a 40 right here. It's on FG, so it is the second and third letters over here. So it matches with the second and third letters over here, which is the T and the U, which means it's matching up with the missing side. And then on the other side we have FE, which is 44. It's the first and second letters, or second and first letters. It's going to match up with the T and the E, which is 11. So we're going to end up with 40 over x is equal to 44 over 11. Then when we cross multiply, we'll get 44x equals 40 times 11, which is 440. So we get 44x equals 440. Then we divide by 44, and we'll get x is equal to 10. These are the notes for similar triangles, or we're trying to find missing sides. So for this, what we end up with is two similar triangles. There's triangle 1. And here's triangle 2. Okay, so they're both similar to each other. On triangle 1, we have a side length of 10. On triangle 2, we'd have a side length of 5. And then we also have on triangle 1, we have a missing side right here. And on triangle 2, I have a side length of 15. So I want to figure out what is the missing side. So what I would do is I would set up a proportion, because remember, to be similar, you have to have the same shape and the side lengths have to be proportional. So we could do 10 over 5, because these two match. The 10 matches with the 5, and then the missing side, which is the x, matches with the 15. So 10 goes with 5. We can do 10 over 5 is equal to x over 15. Or we could start with the other triangle, the smaller one. We could do 5 over 10 is equal to 15 over x. Either way, we're going to get the same answer because we're doing the same things when we cross multiply. If we do this one on the left, we'll get 5 times x equals 10 times 15. If we do it on the right, we get the same thing. 5 times x equals 10 times 15. So whichever way you want to set it up and do it, you're still going to get the same answer. So if we do the one on the left, we'll do 5x equals 150. Then divide both sides by 5. And we'll get x is equal to 30. Okay, let's look at the example. This is a typical, midterm type question. I wouldn't be surprised if there were some questions like this on the midterm, or an AZ merit type question, some kind of standardized test question. This is a good test question. It says a flagpole is 45 feet away from the school building. A 6-foot tall student stands 15 feet away from the building. What is the height of the flagpole? So this one you almost have to make a drawing of. So let's start with our first thing. We have a flagpole is 45 feet away from a school building. So here's our building, and here's our flagpole. It's 45 feet away from the building, so it's 45 feet. And then it says a 6-foot tall student stands 15 feet away from the building. Okay, so here's our student. Student's 6 feet tall, and it's 15 feet away from the building. Okay, and what we want to do is, just like this, we want to go make a giant triangle like that. And what we really have is we have two triangles. We have one great big triangle, which is both of them put together, and then we have a smaller triangle, which is this one. So the thing about those triangles are they are similar to each other. So what we could do is we can use similarity to figure out how big that flagpole is, which we'll call X. Okay, so let's start with the student. Student's 15 feet away. So right here's the 15. That's a small triangle, and it matches with the 45 in the big triangle. And then the 6 in the small triangle matches with our missing side in the big triangle. So we'll get 15 over 45 equals 6 over x. And then to solve that, we can just cross multiply. So we'll do 15x equals 6 times 45. And that'll give me 15x is equal to 270. And then divide both sides by 15. And we end up with x is equal to 18. So that means that our flagpole is 18 feet tall.